So good evening, guys. First, before we start with the actual discussion, let me welcome you on behalf of Sunbeam. I am really glad to see you all. This is the day one where we are going to start with the new venture. This venture is called as DevOps. Now, before we talk about the DevOps, I'll first give you the introduction to what exactly the curriculum that we are going to talk about. So you can understand what dev and ops and what exactly the combination of dev and ops together means, what exactly that we are going to look here. So before we dive into it, let's get a quick introduction to the entire curriculum of it. I already have given you enough about that in the covering later, but let me give you in details like what exactly that you can expect from the course, and you should not have any kind of misconception about it. So this is what we're going to talk about throughout this entire course, DevOps. Now, today and maybe today or maximum tomorrow, we'll be working on the first part of it, where we will talk about Agile and the DevOps Foundation. When I say Agile and DevOps Foundation, you might also have heard about something called as a software engineering. Software engineering is like methodologies or scientific approach to develop an application from start to end, from requirement gathering, from requirement specification, project designing, then project development, it's called the coding, testing, then deploying. So this is kind of, you can say SDLC. This SDLC is governed by the software engineering. Now, SDLC is there since ages. Without SDLC, you cannot complete your project. And that's the reason SDLC is very important. To implement project with the software development lifecycle, there were many models. One of the oldest model was something called an Agile. You might have heard about that. But Agile was having say many problems, and that's the reason another model came into existence called as a iterative model. So iterative model was kind of breaking the project into smaller modules, and still it was a bit difficult for developers and the client to see the project getting completed on time. That's the reason why Agile development came to existence, and people really loved it. I mean, Agile is not only used in computer, it's also used elsewhere. Like for example, construction projects, these are also using Agile development, or Agile, you can call this as a model to get any project completed, not necessarily the computer development, but Agile can be used elsewhere as well. Now, extension to Agile is called the DevOps, and that's exactly what we'll discuss here. So we'll first start talking about what do you mean by software engineering. Inside that, we'll talk about SDLC, software development lifecycle. Then we'll talk about something called as a waterfall. Not that we will dive into it, but just to give us, just to get a kind of a quick introduction to what was waterfall model and why it failed. So we'll talk about that there. Then we'll talk about quickly iterative model. Iterative development it is called as iterative model it is called as. And then we'll talk about the agile development, and inside agile we'll talk about something called as the scrum. What do you mean by scrum, or what are the scrum principles, what are the scrum rules, or what are the scrum users, or something like what are the different use cases where the scrum is used, and what are the scrum's workflow, like what do you mean by sprint, or what do you mean by sprint planning, or what do you mean by sprint, what do you mean by sprint development, so on and so forth. So this is what we'll talk about in this particular part. It's called as Agile fundamentals. Under DevOps, we'll talk about something called the DevOps itself, and very important part, DevOps life cycle. This is called as a DevOps life cycle, and there are 8 different stages in it, starting from the plan, code, build, test, release, deploy, operate, and monitor. So that's infinity symbol you might have seen elsewhere. This is what we'll be talking about inside the DevOps lifecycle. Maybe later today, we'll finish it off. It's like DevOps lifecycle, which is what you are going to see hell lot of tools, and those tools we'll be studying for next couple of weeks. So that's the plan. So I'll explain what different tools we will be talking about, or every tool that is needed in every stage inside lifecycle, and then we'll start talking about those tools one by one. Now, once we understand what is the DevOps lifecycle, we'll start or we'll jump directly into the next part, and something called as the Linux basics. So here we'll understand the Linux. As I always say, when you are talking about DevOps, you have to be, I don't say you must be expert, but you should know Linux very well. Because without Linux, none of these tools work very well. Of course, there are few tools which are Linux specific. Like for example, Kubernetes. Kubernetes cannot be installed on Windows. You have to have a Linux on top of it. I mean, Linux to install Kubernetes there. When you can install something as a Minikube on Windows, it's okay, but Minikube is not used in production. If you want to go for production, if you want to create your own server, there you want to create a Kubernetes cluster, you have to have Linux on that machine. So Linux is the future, and that's the reason we'll start with the Linux basics. What different things we'll cover in the Linux? We'll first cover the basic commands. When I say basic commands, this include date command, ls command, so on and so forth. So these are very simple and basic commands. Then we'll talk about file systems, file system commands like how to create a file, or what do you mean by a absolute path, relative path, what's a directory structure, how the root, bin, home, and there are dozens of other directories used in Linux. What exactly the meaning of those directories are, where exactly those directory will be important when you are starting with the DevOps career there. Which are the more important directories you should remember, like etc directory. It is where you can see the configuration is stored, or USI directory that's used for user base, and so on and so forth. So that is the FS related stuff. Another important topic, something called the users. So basically, Linux is very secure operating system. That's what people generally say. Why is it secure? Because there are permissions which are applied on the user level and of course the file level. So user management is very important in Linux, and that's what we'll be covering right after we are done with the FS. Another important point is something called as a text files. Most of the times we will be working with the text files when it comes to Linux, like configuration files. All of them are text files. So we'll be using some editors like a Vim editor or Nano editor, and there are a bunch of other editors out there. So file system, text file related, the commands, we'll talk about them there. Then we will talk about archives, another important points, and the zip files, archives, and something called as the zip files, or you can call them as compressed files. So archives and compressed files like tar file or tar.gz file, gzip file, so on and so forth. So from the Linux point of view, you need to know the basic command, and what I mentioned here is our kind of foundations of it. Without this, there is nothing you can do in the DevOps, because most of these tools, as I mentioned, will require you to work with Linux. Yes, another important point, and I can't forget that, this is called as a networking. So how the networking is kind of managed, or networking command managed inside the Linux, like for example, setting IP address or doing the SSH, or maybe connecting to the remote machine, or maybe you can say working with the remote shell, SSH is called as, or SCP is called as, to transfer the data from one machine to another machine, and all of that stuff. So all the networking related commands and other stuff we will be working or will be talking about here in the Linux part of it. And this is important for us because without this networking commands, you will not be able to work with the cloud. So this is what we'll be talking about inside the Linux basics. So I'm not expecting all of you to have a Linux knowledge. So Linux is not a prerequisite here. If you know Linux, very well. I mean, it's kind of good for you. But if you don't do it, it's all right. This week we'll be working on the Linux part of it. So we'll get ourselves equipped with the Linux knowledge. I didn't mention this. I'm going to assume that when I say Linux basics, it also includes the installation. How do you install it? Tomorrow I'll talk about that. And basic configuration, like how do we install it and how do we basically configure it? Basic configuration, not the advanced configuration or hardening here, but the basic configuration of it. So this is what we'll be talking from the Linux point of view, right? This week we'll be finishing with that. Next week we'll be talking about, or we're starting with the next big topic called as AWS. It's a cloud. And probably you might be knowing it. Everywhere you can see the cloud is getting used. I mean, without you knowing it, you are using cloud already. For example, if you are watching a match on Hotstar, or if you're purchasing anything from Amazon, or if you're streaming a movie on YouTube or Netflix or any other platform out there, you already are using cloud. Without you knowing it, the cloud is already there in your life. When you say cloud, there are many cloud providers out there. Out of that, more than 50% of the market share is captured by AWS. And that is the reason why we are going to talk about AWS here. So AWS being not only the standard, but also a kind of, you can say, leader in the market in the AWS category. And that's the reason why we are going to talk about this a lot. So probably AWS is our, you can say, the cloud provider, and we'll be kind of using it almost all the time. So when I say cloud, we'll be talking about multiple stuff there. For example, when I say cloud, you need to understand what exactly do you mean by virtualization. This is the basics of cloud, virtualization. When I say virtualization, this will give you an option to create the virtual machines. So virtualization comes in 8 different flavors, precisely 7. When you say 7 different flavors, like desktop virtualization, network virtualization, storage virtualization, application virtualization, something like hardware virtualization, software virtualization, software means OS virtualization, so on and so forth. Out of that, we'll be talking a lot on hardware virtualization here, and something called as the OS virtualization later as a containerization. So here in the cloud, we'll be talking about a prerequisite called as virtualization. Without this, you cannot look at the cloud. And then we'll start talking about the AWS. Like, what do you mean by AWS provider, or what different services it provides? And out of that, we'll be talking about EC2, Elastic Compute Cloud, it is called as. S3, simple storage service, it's called as, used for storing the data in terms of buckets, or object storage is known as. We'll be talking about VPC, very basic and very important service. VPC, we'll be talking about auto scaling. Sorry, we'll be talking about auto scaling. Then we'll be talking about something like maybe Route 53. It is a DNS. Route 53, which is like a DNS in AWS. We'll be talking about something called as a Lambda. And then, in the first half, we'll be talking about these services. Once we are done with almost everything in the DevOps, then we'll talk about the DevOps on AWS. So DevOps on AWS is a totally different type of services, like code commit or code build, and so on and so forth. So there are multiple options available here. Whatever the tools that we'll be looking at, like something called the CloudFormation, that's also is a part of AWS, or Ansible, that is the configuration tool, Terraform, that's a configuration tool. All of them are directly or indirectly associated with AWS, and that's the reason why AWS is going to be important for us. We'll be deploying our project inside virtualization and probably later in containerization. That's what I said. In the first half, we'll talk about the AWS with those basic services. Later, we'll be adding the DevOps with AWS. Once we're done with Docker, we'll come back here and talk about ECS. And once we're done with the Kubernetes, we'll come here and talk about EKS. EKS stands for Elastic Kubernetes Service, and ECS stands for Elastic Containerization Service, or Container Service it is known as. So this is something we'll be kind of using AWS services in this part, or maybe you can say in this module of this course. Now, I know AWS is something which is leader in the market, but that doesn't mean that's the only cloud provider out there. There are many other cloud providers out there which are also popular. And to give you a context, two of them are very important. One of them is called as an Azure from Microsoft. Another one, something called as a GCP. So the services, not all of them, but these services like EC2 instance, like virtual machine on AWS, I'll give you a small demo of how do we create the same services here and here, so that you can also side by side start learning the GCP and Azure on your own, right? So when I say something like EC2, this is the basic service without which you cannot do anything on AWS, like the installation, or you can say deployment of your application. So I'll talk about EC2 on AWS. This is called the virtual machine on GCP and virtual machine on Azure, right? So just to give you a kind of at least one service demo, we'll be going for this, EC2 on GCP and Azure. If possible, we'll talk about S3 at least to a small level. Like EKS is on AWS, there's a service which is very popular called as a GKE, GCP or Google Kubernetes engine. So I'll be talking about GCP, EKS like Kubernetes on GCP called as GKE. So when we are done with the Kubernetes, we'll come on AWS and we'll create EKS, and we'll come here on GCP and we'll create something called as a GKE, and we'll come here and called as AKS, Azure Kubernetes Service. That's important. So that's the reason few services I'll show you on all three, like EC2 on AWS, virtual machine on GCP, and virtual machine on Azure. So similarly, EKS on AWS, GKE on GCP, and AKS on Azure, right? These are important points. As a DevOps engineer, you should know all the cloud providers options available there when you are installing the Kubernetes in the cloud. So we'll talk about all of this there whenever it is needed. So that will cover our cloud part of it, and cloud is the core part of it. Without this, you cannot get anything available on the public IP address, or you can't access it outside of your local network. So you have to have the cloud with you. That's what we are going to cover here. Now, once we are done with the cloud, maybe you can say the default, or you can say the global services available on top of any of them, or maybe the AWS precisely, we'll move further and we'll start creating the resources. Like, for example, I want to create an EC2 instance to, let's say, install my application or to deploy my application. But it's not like one environment. I need, let's say, 5 environments. So, or maybe maybe let's say multiple environments like this, like one for testing, one for, let's say, staging, one for something like pre-production, one for production, one for final production, so on and so forth. So I have to repeat all the steps one by one. For example, in AWS, you get something like the management console. And when you get a management console, there you go to the GUI and start creating the EC2 instance. Let's say I have to create 10 EC2 instances, two for every environment. I have to repeat that steps every single time. I have to repeat the same steps 10 times. Fine, I'm ready to do as well. But can you see that if I'm doing it well for the first time, it's not guaranteed I will exactly follow all the steps in the second time. That means I may miss few steps and it may not work very well second times. And I have to do it 10 times. You see how much time it takes and how many mistakes I can make. So to avoid these kind of mistakes, we do not want to create all those resources or infrastructure resources, to be honest, on the AWS manually. Instead, we want to write the scripts and execute the scripts to create all the resources automatically. Now, how do you do it then? To do it, there is a concept called as IAC. It is known as infrastructure as code, which means you will write some scripts precisely. You will write some scripts in order to create the infrastructure on AWS, on Azure, or on GCP. You decide where you want to go for it. So IAC, it is the one which will help you to write the scripts and get your infrastructure created just by executing those scripts. That's why it is important for you to know how do we write those scripts using IAC as a kind of a concept. But to execute those scripts and create the resources on internet, we need certain tools. And this is the tool that we'll be focusing on, Terraform. Terraform is a kind of a tool given by a company called the HashiCorp. So HashiCorp Terraform is very well known to create the resources on any of those cloud providers, which means the script can be used to create the resources on GCP or AWS or Azure, or at the same time on all three at the same time. So as I mentioned, I want to create a EC2 instance on AWS, virtual machine on GCP, and virtual machine for Azure at the same time. I don't want to do that manually. Instead, I would write the Terraform script and get the job done. So in Terraform, there is a concept called as modules, and we'll be writing a hell lot of modules out there. So we'll understand like how is it possible for us to communicate with AWS a lot from Terraform. How do we create the different modules? How do we make it reusable? And how do we create the infrastructure using this? Now, when you say Terraform, Terraform is a kind of a public tool. I mean, it's kind of, you can say given by HashiCorp, which can work with any of the cloud providers there. I mean, not necessarily only GCP, AWS or Azure. There are other cloud providers also with which you can, write the scripts in Terraform and get the job done. Not only that, it can also work with different applications as well. Like it can work directly with the Kubernetes, Docker, and other stuff also. But this is very popular when you are going to create the cloud infrastructure. When you are going with AWS, AWS also provides a tool called as a cloud formation, or it is something called the CF. It is AWS specific. In a sense, if I want to create any of those resources on AWS, I'm talking only about AWS here. On AWS, instead of creating them using management console or the GUI, I could write the scripts and pass that to the cloud formation. So this works like Terraform, but this is specific to AWS. Terraform, on the other hand, can work with all these cloud providers. CloudFormation works with only AWS because it is given by AWS, it's given by Amazon to create the infrastructure programmatically on AWS. To work with this, both, I mean, all these cloud providers have given something called the SDK. I mean, those who are programmers might also know that SDK stands for Software Development Kit. So those SDKs provide the APIs, and those APIs will be consumed by both of these tools. So AWS APIs are consumed by Terraform as well as CloudFormation to get something or to get all the infrastructure created programmatically. GCP API will be used by Terraform. Azure API can be used by Terraform, not by the CloudFormation. CloudFormation is only used by, it's provided by AWS or provided by Amazon only for AWS. So this is specifically for AWS stuff. It's called as CloudFormation. So it is an extension to the cloud, I can say, or extension to the AWS here. But this is a kind of script that we have to provide. It's not a YAML script, to be honest. When you talk about Terraform its own language, Shubham. CloudFormation has its own syntax. It's like a YAML, but it's not exactly YAML, to be honest. Both of them are having a different syntaxes, and we have to learn that syntax and we have to get the job done there. But in addition to creating all those resources using GUI, we'll be writing some scripts called as infrastructure as a code and get the job done programmatically. So once the script is ready, I can execute it 10 times to create 10 resources or 20 times to create 20 resources. As simple as that. It's like a program you are developing. Once the program is ready, you can go for executing it as many times as you want. Right. That's called as a HashiCorp configuration language. Yes, Sandesh. That's used by Terraform. It has its own syntax. We'll see that syntax in this particular model. Now, once the infrastructure is created, let's say, for example, I've created EC2 instance, not one or not two, let's say 10 of them. Now, I want to configure them, install Linux. Now, maybe Linux is already there. We'll assume that because by default, when you create maybe EC2 instance or virtual machine in the cloud, it will also contain the operating system on top of it. Like, say, for example, Ubuntu, Linux operating system on top of it. Now, what? If I want to, let's say, install MySQL there, or if I want to install Apache there, or if I want to copy my code there, I have to keep configuring my resources. Now, if I want to do it in front of it, sit in front of it and do it myself, it takes a lot of my time. It takes a lot of my efforts. And again, same problem. I'm a human. You can't trust human anymore. So you may not, or that human may not be able to perform well. Given a scenario, given the stress that we are having, we may miss the steps here and there, and it may not work all the time. And that's the reason company does not believe in a human beings anymore. They want machine to automate the job. And that's where the next tool comes into picture, something called as configuration tools. So this is the category, configuration tools. Inside that, there are many other tools, something called as Puppet or Chef or SaltStack. There are many tools, but out of them, Ansible is the one which shines a lot. And that's the reason why we have chosen Ansible here. Ansible is very popular compared to all of the others. And this is backed by none other than Red Hat. That's the reason why industry trusts Ansible a lot. So inside Ansible, we'll first learn the syntax called as a YAML. So YAML is the syntax, or you can say it's a language which is used by Ansible to create the scripts. Those are called as Ansible playbooks. So Ansible playbooks is what we will be writing here, and then we'll be creating the Ansible resources. So there are multiple ways you can deal with it, and I'll show you all of them there. Then we'll talk about Ansible Tower. It is a kind of, you can say, GUI version available for enterprise editions, but it's available for evaluation purpose only. But we'll see like what is a tower and how we can use it in the real world. So it's a very small part, Ansible, which is used for configuring the entire project. When I say configuration, that means here you are creating the infrastructure using this or that, and here you are configuring those resources. Like, for example, virtual machine called EC2 will be created by using Terraform, and it will be configured by using Ansible. That's a kind of the job these two tools are having. So this is infrastructure creation and this is infrastructure configuration. That's why it is known as a configuration tool. Okay. So again, if you think about this, you are knowing now in this particular case, what is Agile, what is the DevOps, then you will be knowing the Linux part of it. Then we'll talk about the cloud. Then we'll talk about IAC, and then we'll talk about configuration. This is where the installation part is almost over. So installation means like infrastructure creation or configuration. So this half is like the infrastructure is already ready. Now what? Now we start deploying the application. Now, if I want to deploy the application, as I said, there are two ways you can deploy it. Actually, three ways, but one is already deprecated. So we don't consider that anymore. So when I say this is what we want to deploy an application, this is called as the application deployment. So there are three ways. One is called as a traditional deployment, means the deployment using a physical machine. It's gone, it's deprecated. We don't do it anymore. Either we do it with virtualization, it's called as virtualized deployment, and another one is something called as containerized deployment. Virtualized deployment means using virtual machines, as I mentioned, EC2, for example, or virtual machines on GCP, or virtual machine on Azure, for example. This is where we may deploy our application if needed. But most often, like for example, you must have seen you are watching a, let's say, live match on Hotstar, and never you will see your screen is frozen or your match has stopped in between. Never has it happened. Netflix, when you are watching a movie, no matter how many people are watching at the same time, this application will never crash. Like Hotstar, for example, or Sony, for example, those live matches, if you see, there are millions of people watching at the same time, but it never crashes. How is it possible for them to create an infrastructure that never crashes? even after millions of people are watching at the same time? The answer to this is called as containerization. This is the one which is the secret sauce behind this entire, maybe you can call this as a entire entire recipe here. This is a secret sauce called as containerization. So when we want to deploy the application in the real world today, the most important one, or the mostly used pattern, or mostly used deployment strategy is called as the containerization. And the containerization is something which can be done by using a tool which provides a containerization service. Now, which tool it is? This tool here, which provides a containerization, is called as Docker. This is my personal favorite area, Docker, Kubernetes, and so on and so forth. So under Docker, we'll first understand what do you mean by containerization? What do you mean by OS virtualization? I mean, containerization is called as an OS virtualization. Just for your understanding, this is called as a OS virtualization. OS virtualization. Under Docker, we'll be learning many different parts, like parts of Docker. For example, we'll start with something called as a Docker images. Then we'll start talking about how do we manage the containers, like create container, run container, start container, stop container, delete container, so on and so forth. Then we'll talk about Docker volumes, like how do we persist the data outside the container, because containers are read-only, containers are immutable. In a sense, once you create a container, you put the data, it will store it for temporarily. If the container is gone, the data also will be gone. So if you want to persist that data, you have to take that data outside the container, which is done by using volumes. Then we'll talk about Docker networking, very important concept. This is the way we can make some private network or public network and make some data publicly accessible, or maybe we can hide the data from public access. It's called the Docker networking. So Docker volume, Docker networking, containerization, they're the basic stuff there. Maybe I can go for service deployment and so on and so forth. I'll put the service on hold for a minute, but this is a kind of, the basics of Docker. If needed, if we are interested, we will go for enterprise Docker as well. This is where we will see like the GUI version of Docker, which is available for enterprise edition. We'll talk about that at the same time when we go for Docker. There are two versions of Docker. One is like open source, called the community. Another one is called an enterprise. So enterprise is it's like a paid version. We'll go for evaluation version of it. But at least we can see like how the Docker is kind of used in these particular scenarios. Forgot to mention one more time. This is important one. This is called as the this is called as a port forwarding. And there are many other. It's not like it is the only one, but there are many other points that we'll be covering when we go for Docker. This is something which is a heart. Both Docker and Kubernetes, both of them are the heart of this entire DevOps. Why DevOps shines, or why DevOps is required? Because of these two tools. Something as a Docker and something as a Kubernetes. The Docker is very famous because of something called as microservices architecture, and we'll be talking in details like what do you mean by microservices architecture, or what is the difference between microservices monolithic and monolithic architecture? What are the advantages of this? How the microservice architecture can be implemented? What different, the way they can communicate with each other, the standards, what do you mean by message queue? What exactly the way the microservices will be developed in the real world, and the project that we'll be working on, that also is a microservices architecture project. So we can see how to Dockerize it. Dockerize means creating containers for running your microservice application. It's called the Dockerization or containerization. So how do we Dockerize that application? We'll see in details of it by creating custom images, by pushing the images into something called as a Docker registry, and so on and so forth. There are so many things we will be talking about in this part, Docker. This is my personal favorite. So we'll be talking about Docker a lot in that case. Now, when you are having, let's say, 100,000 containers of a particular application, to make it highly available, there has to be someone to create the container, to manage the containers. If the container stops in between, you have to restart it. Who does that? The tool which does that container management job is called as a container orchestration tool. Orchestration is the way you are going to manage the containers. Now, who does that again? It's orchestration, and there are 4 very popular orchestrations out there. One is called as a Docker Swarm. Another one is something called the Kubernetes. Then is Apache Marathon. And you can see, I mean, there are many others, but these are popular ones. So we are going to pick the important ones. Docker Swarm because it's very simple, and Kubernetes because it's very powerful. So we'll understand the simpler architecture first. We'll understand the concepts. We'll see like how the service infrastructure works, or what do you mean by, why am I not writing it? So we'll see what do you mean by services. I'm talking about a Kubernetes here, or we'll first talk about Docker Swarm. I'll say DS for Docker Swarm. Under Docker Swarm, we'll see what do you mean by service. This is the core part of Docker Swarm. Service, which is like a load balancer. How do we load balance it? How do we go for configuring it? I mean, multiple application or multiple containers, which is known as the container management. What do you mean by stack, and so on and so forth. There are many things which are very simple in Docker Swarm, but you should know that, so that Kubernetes concept will be very simple. Under Kubernetes, there are a lot of things. I mean, Docker Swarm, you can understand that hardly in a day or two, nothing more than that. It's like a very simple word, but Kubernetes require more than at least a week or so, because Kubernetes is very huge. So under Kubernetes, we'll start talking about the pods, important points. So we'll start talking about the pods, which like pod management. We'll talk about the secrets. We'll talk about a config map. This is where we'll put the configuration of our application, config map and secrets. It's called as, secrets. Then we'll talk about something called as a volumes. This is called as a persistent storage. Instead of saying volume, I can call this as a persistent storage. PS, it is known as persistent storage, which is converted into volumes later, and probably we can call it as an ingress service. Four types of services. Probably we can go for something like the namespaces, and there are many other, so on and so forth. So we'll talk about all of this stuff in Kubernetes. Believe me, if you ask me what is the most important part in the DevOps, I would say this is the one. It's called the Kubernetes. It's very difficult, at the same time very important. This is the secret sauce, as I said, to make the application highly available. So actually speaking, what happens here is, when you are running an application here, say for example, my application is running inside the server, and if the server is getting used by, let's say, only one user at a time, there is no problem, so only one user is talking to the server, having no issues in that. But when you are having, let's say, 100,000 users talking to the same machine at the same time, the problem will start. I mean, you will start facing the problem, or you can say the problem will start arriving there. This is where, the Kubernetes like the orchestration engine will come to your help. So when you say one user, there is no problem. But when there are so many users who are accessing the application at the same time, the application will start crashing, because the application will not be able to sustain that load. To solve this kind of problem, this is called as a scalability. To solve the scalability problem, or to make your application scalable, we have two options. One is called as horizontal scaling, another one is called as a vertical scaling. These two guys, Docker Swarm and Kubernetes, these are very famous to make your application horizontally scalable. Horizontally scalable. This is generally called as horizontally scalable, highly available application. When I say highly available, that means application will never go down. Like, have you ever imagined Amazon going down? Have you ever imagined Netflix going down? Hotstar going down? Sony Live, when the match is live, is it going down anytime? No, it does not. It never will, because of this secret, horizontal scalability. Horizontal scalability, or highly available or high availability, can be implemented by using the orchestration engines or orchestration tools like Docker Swarm or Kubernetes. In the real world, we do not use Docker Swarm anymore. I mean, we do use it, but only for the small projects. But thinking about, let's say, live match, you have no option but to go for Kubernetes like services. There are many other options out there, but Kubernetes is really shining a lot. That's why we have chosen Kubernetes there, right? So this is the one which is kind of important for you to to install it, to configure it, to create a cluster, and so on and so forth. Unfortunately, Deepak, unfortunately, CKA, it's too much. CK, you can't go for that because CK requires you. CK stands for Certified Kubernetes Administrator. It requires you to have a very strong Linux knowledge, very strong networking knowledge, and then very strong Kubernetes administration knowledge. So we don't have that much of time, because if you want to go for CK, at least 5 weeks are required to just go through the CK part of it. We'll be sending a 1.5 week. So probably we may not be able to go for CK, but we can definitely go for CK AD level, application developer, for sure. So that's what I can guarantee you. CK in that short period is not possible. There are many things which we cannot see in this particular short term, like cluster management. If the cluster is going down, how do we manage it? How do we making the cluster up and running? How do we make the services up and running? And so on and so forth. That reminds me, when we go for Linux basis, I forgot to mention one point which is important, called as the service management. Service management using something called as the sysctl command, like systemctl command. This is a very important command, because without this, you won't be able to see what, whether the services are running or not on Linux. So that's the one, right? Okay, so when we are talking about this, it's like a very important tool in the entire DevOps. So we'll be spending a lot on this particular topic, right? So we'll see what do you mean by that and how do we take care of it. But I can guarantee you, you will be kind of afflicted to CKAD level, not A level, but CKAD level. So Certified Kubernetes Application Developer, it is known as CKAD. Okay, now you have got the entire infrastructure ready here. You have got the containerization tool called as Docker. You have Dockerized the application. You already have got the Kubernetes installed on your machine. Its cluster is running very well. Now you want to keep running your application, keep building the application, keep deploying the applications automatically. I don't want to do it manually. Whenever the developer checks in the code, let's say in GitHub repository, I want the deployment to happen on Kubernetes or Docker Swarm or somewhere in the cloud also automatically. How do you do that? This can be done by using something called as Jenkins. This is called as a CI/CD pipeline. CI/CD stands for continuous integration, continuous delivery, or continuous deployment. Both of them are almost similar. The only difference here is in continuous delivery, the deployment happens manually, and continuous deployment happens automatically. That's the only difference, but otherwise both of them are delivery and deployment. Both of them are going to do the same job. If you want to do that deployment automatically, building the application, testing the application, packaging the application, maybe deploying the application automatically, we have to go for a CI/CD tool. Now there are many tools out there. These three are pretty much important. One is called the Jenkins. This is the one on top, you can say. It's like really shining in the CI/CD pipeline, because this tool provides both CI as well as CD capacity or capabilities. CI for continuous integration and CD for continuous delivery and deployment. And Jenkins is supporting both of them. Like Jenkins, there's another one which is developed by Microsoft. I should call it the Microsoft, but it's like developed by GitHub, called the GitHub Actions. This is also very popular, and we'll be talking about both of them. So Jenkins plus GitHub Actions. Now, both of them are CI/CD pipeline tools, but there's another tool called the Argo CD, which comes under something called as a GitOps. GitOps, it is known as. So what is a GitOps and how does it work? We'll talk about them later, but this is another very important tool which is used when you are having the Kubernetes in picture. So when you are having Kubernetes in production or Kubernetes in environment to run your application, you have to deploy the application automatically by using something called as an Argo CD. And Argo CD is also very popular. Here CD stands for a continuous delivery or continuous deployment. Now, when it comes to CI/CD pipeline, we'll understand few important concepts called as the pipeline first. A pipeline means it's a sequence of stages. Like for example, taking the source code from your GitHub repository, building the application, maybe unit testing the application, packaging the application, end-to-end testing of your application, getting the defects, or you can say SonarQube implementation of it. Sorry, I need to write it. SonarQube implementation of it. This is also important one, because without this, you won't be able to understand how quality code that you are writing. It's a SonarQube. It's a very popular tool which is used for testing, not testing, I would say, but checking what is the test score. We'll create some artifacts. You can see the entire dashboard on the Sonar Cube, like what's currently the case there. It's very important, and probably it supports many other languages as well. It supports Java, JavaScript, TypeScript, C++, something like Kotlin, something like Swift, and others. So Sonar Cube is very popular, and we'll be integrating that inside the Jenkins. Along with the CI/CD, not too much details, but at least I'll give you a small idea about something called as a Selenium. Selenium is very popular, called as a testing tool. As I said, we will not spend too much of time into it, but at least one session I'll spend talking about how do we get the application well tested by using Selenium. It's called as a web application testing, web UI testing. This is done by using Selenium, and Selenium will be integrating inside the Jenkins here. So we'll see like how does it work. Selenium part of it, which is kind of used for UI testing, web UI testing, Selenium. Then we'll go for creating the pipelines called as the scripted pipelines using a scripting language called as a Groovy. Scripted pipeline it is known as. The one which I mentioned here, pipeline, this will be created using dashboard, Jenkins dashboard. There are two ways you can create a pipeline in Jenkins. It's called as a scripted pipeline, and another one is called a GUI or dashboard pipeline. So we'll be looking at both of them. And this scripted pipeline, we have to learn a language called as Groovy. And it's very simple. Don't worry. It's not a kind of a very big language as such. It is kind of similar to Java. So those who know Java, for them, it's like you'll feel at home. It's very simple, even simpler than Java. So we'll talk about this in terms of Jenkins scripted pipeline. It's very important for you to know how do we do that scripted pipeline, because GUI you will again forget the steps later. So precisely, it's better to write the scripts inside even the Jenkins also. In GitHub Actions, the good thing here is we are going to write the code in YAML. So precisely YAML we already have seen earlier there. So probably in this particular module, you will be already knowing it. So probably you will have to, you will face no problem with that YAML. By the way, I didn't mention here the Kubernetes development, or you can say Kubernetes, you can say the interfacing will be also done by using the YAML. So YAML is used at multiple places. You'll be using that YAML for Ansible purpose. You'll be using that YAML for Kubernetes purpose. You'll be using that YAML for something like the GitHub Actions purpose as well. So YAML is almost used at 1, 2, and 3 levels. So again, your GitHub Actions is YAML. Kubernetes also is YAML, and Ansible is also using YAML. Okay. So again, in CI/CD pipeline, Jenkins, GitHub Actions, and Argo CD, 3 tools we'll be talking about. This is especially needed when you are having the K8s, that's like Kubernetes in picture. So when you're having Kubernetes, you will definitely go for Argo CD. So that's what the deployment strategy will be using here. Automatic deployment strategy will be using here. This is called as the CI/CD pipeline, continuous integration, continuous delivery, or continuous deployment. Okay, now once, say, imagine your application is kind of running there. It's kind of installed, it's kind of running, it's kind of automatically built, tested, and so on and so forth. Now it is running. Now what to do with that application? Now, very important, you have to keep checking if the application is really working fine or not. This is called as monitoring. It's very important to know that whether it's running or not, right? If it is not running, you have to take necessary actions, and that's why monitoring is very important. So the monitoring can be done by using various different tools like Nagios. Nagios is a pretty much global tool, can be used with or without Kubernetes, or with or without containerization. This can be done or this can be installed to configure many different services like database services, microservices, any type of services which are running or not. You can check them by using Nagios. We'll use Nagios there. But before we use Nagios, because we'll be using Kubernetes a lot, we'll be talking about the Prometheus and Grafana. Very important in terms of monitoring world. So in monitoring world, we'll be talking about something called the KPIs. KPIs. How do we create our own metrics with Prometheus and so on and so forth? We'll be installing Prometheus and Grafana. Prometheus has its own language, So this will, it's called as a PMQL or PQL. It's called as Prometheus Query Language. It has its own query language. So Grafana uses that query language in order to talk to the Prometheus and gives you a nice little dashboard. So this is like a monitoring dashboard. This will be created here. Later, using Nagios, Grafana will not allow you that, but Nagios does allow this. So in terms of Nagios, we'll be having so many plugins out there, So Nagios allows us to configure many different plugins, and those plugins, one of those plugins is called as a notification. And this notification plugin can be connected to different notification channels, like for example Slack, or for example say WhatsApp, and I'll show you, like, if something goes bad, how you can get a Slack message directly by using that Negio service here. Let's say MySQL is running and automatically it stops for any reason. You will automatically get a message on Slack saying, hey, this service is going down, or this service has gone down, So probably you will get the dashboard, and you can also see the Nagios plugins out there, which will help us to configure many different things. Notification is just one of them. So just giving a heads up here. Something goes down and Nagios will send a message to Slack. It can also send a message to WhatsApp as well, but this has to be configured very well. This WhatsApp or Slack reminds me, in case of AWS, there's one more service we'll talk about, something called the SNS. It's called as a simple notification service, which will help us to send a message directly to your text, or you can say your mobile. It's called the text messages. This can be sending text messages on maybe you can call it an Android push notification or iOS push notification. That's called as SNS in case of AWS. Anyways, so you will see here, you can configure Grafana, Prometheus, and Nagios under monitoring part. So this tool, or these tools precisely, will help you to see like what's currently going on. So this will cover all of our DevOps part. As I said, like, DevOps is very important in today's world. Even if you are a dev, even if you are a tester, even if you are a kind of an operations person, DevOps is very much needed. So how this course will help you then, or how can I help you to get the job very quickly in DevOps category or DevOps side? So towards the end of this entire session, entire course, I'll be talking more on how do you get your resume prepared for the freshers experience, or even a non-IT, to talk about, like, all the different stuff that you have seen here. How do we frame those questions, or how do we prepare for interview questions? Last 2 or 3 sessions, I'll be kind of talking about interview sessions or interview questions. We'll see like how to frame the answers, what different things to be included there, and so on and so forth. So this is especially last 1 or 2 sessions, or maybe 2 or 3 sessions, will be reserved for talking on the interview questions. Okay. On top of it, I'll tell you how do we prepare your resume as well, like resume building. There are special things you should mention in the resume to maybe get your resume eye-catching. So this is resume preparation. We'll be talking about that, and then we'll talk about different things, or you should talk about in your so-called QA session or question answer sessions in your interview pattern. So all of these things will be kind of done in this entire, maybe you can say, entire course, and so on and so forth. Okay, now to understand this very well, just talking about theoretically or just giving you a hello world application will not suffice. That's the reason we'll be working on a very important and very big something called as a capstone project. Pranav, this is the answer to your question, you see. So what exactly this project is about? This project will help us to continuously deploying an entire e-commerce application developed using microservice architecture. I'll show that architecture in a second, but this architecture will kind of tell you the project has microservices developed not only in one language, but in multiple languages like Python, JavaScript, .NET, Rust, Java, so on and so forth. Now, why is it important? It's important because you will come to know how do you containerize Python application, or how do you containerize JavaScript application, Java application, Rust application, and whatnot. You are not going to develop this application. One more time, this application is not going to be something like a developed here. Instead, we'll be getting a ready-made code. I'll show that here, in fact. So you will get to know like what is that. So if you go back here and search for Open Telemetry, this is the one. It's very kind of, you can say, important, or you can say it's a very big project. You can see a high quality, ubiquitous, portable telemetry to effective observability. It's very popular also, and this is having a kind of, you can say, the good architecture also. So this is the one that you can, we can use in order to deploy it on EKS and our own, let's say, Kubernetes cluster as well, using CI/CD pipeline as a continuous deployment, Terraform to create the EC2 instance or infrastructure on AWS, so on and so forth. So you can see that if you are a dev, you can see like how does it work or what different type of services here. So you can see that it is having a Go service, Erlang service, .NET service, C++, Java, JavaScript, PHP, Python, so on and so forth. So these guys have showcased like how the microservice application to be developed. And if you go for something like, the demo, and if you look at the architecture, this is the architecture of this service. Look at that. It's very big architecture you can see here. So this is like the front end proxy, which is like an envoy. We'll talk about that when we go for implementing the Kubernetes implementation there. What is an envoy and how do we do that? So load generator, internet means anyone who's talking to that front end will come from here. It could be like website or it could be React Native. Maybe you can say hybrid application. This will talk to the actual front end, and the front end is going to talk to different services like ad generation, currency, cart, something like the checkout service, shipping service, and so on and so forth. You can see there are a bunch of services there. There are a bunch of communication mechanism, like they are using gRPC. There is something like a TCP, direct communication here. There is something like HTTP, means it is using REST API, or maybe you can say GraphQL API, and so on and so forth. This is the service diagram here. We are not going to develop this application. This application already been developed. This is not my application, by the way. This is an open source application. Why am I choosing this application? Just to showcase you don't have to have any development knowledge when you are going to be a DevOps engineer. Having development knowledge is good, but it's not mandatory, because as a DevOps engineer, your job is not to develop application. Your job is to get it automatically deployed on certain platform like AWS, Azure, GCP, or Kubernetes, or Docker Swarm, so on and so forth. This is the choice of your company, like where it has to be developed. But you can see that this is a kind of architecture that will be deploying in maybe Kubernetes here. Deployment is really painful. I'm telling you right now, it's very painful. There are so many things that you configure here. But once we understand all of the stuff that I was mentioning earlier, this part here, doing it is like a breeze, So this is a kind of a good architecture for you to understand how do we containerize the application, how do we deploy the application, which is developed in different languages. And which languages have they used here? See, .NET, that's C++, Go, Java, JavaScript, Kotlin, PHP, Python, Ruby, Rust, TypeScript. So this will give you enough idea about in any language, if you can, application developed in any language, if you can containerize it here, you can definitely do it for other applications as well. And that's the reason why it's important for us to get something like this deployed in the real world. I'll be doing it thrice, once in AWS using something like EC2 instance. Then we'll go for Kubernetes cluster, our own cluster on our machine. And later on, we'll do the same thing inside EKS, which is like on AWS. I forgot to mention one more thing in this one that reminds me. When we are going for Kubernetes, there also we'll be talking about something called as a Helm charts. Another important point, because I don't want to keep deploying that single service at a time. Instead, we'll be talking about something called as the Helm charts. These are called as the Helm charts, and this will help us to deploy the application in Kubernetes in a simpler way. So think about a chart as a package. So you want to deploy this this application here. You will create a chart. I mean, these guys also have given the chart as well. They also have kind of given an instruction like how do we do that, and so on and so forth. This is not complete in the complete implementation of it, but this is what they have done it. So we'll be doing it from scratch. So probably this will help us to understand all of this different type of applications to get containerized in Docker Swarm, and then we'll do it on Kubernetes twice, once on our local cluster, and then we'll do the same thing on EKS on AWS. So this is a kind of, you can say, a big application that we are going to deploy in multiple different ways on AWS using EC2 instances, later on our Kubernetes cluster, and later on we'll go for on EKS. Again, it's a Kubernetes cluster, but we'll be doing it on the cloud on AWS, right? So I think Pranav, that answers your question. Asynchronous mechanism like gRPC and RabbitMQ. I think Ashish, you also can see here, these guys are using something like a gRPC. So our implementation, our project that we are going to implement here, deploy here, by default, they are using gRPC. So this will give us an idea about how do we make that application continuously available. So that's again a challenge for us. We'll see that challenge when we go for deploying that application. So here we are going to containerize the application and maybe running it on Docker, first Docker Swarm, then Kubernetes cluster, I mean local Kubernetes cluster, and later on it will be on EKS on AWS. I didn't mention it. This has to be done for our own practice. Of course, I'll give you an assignment or I'll show you the steps and you will do it yourself. This will be done on top of EC2 instances as well. I mean, EC2 instance means it's a virtual machine. EC2 instances as well. I'll show you how do we do that later. Now, this will help us to prepare ourselves for interviews. So I'll also guide you how do we prepare this for your interview questions. I mean, this is something that you will put in your resume. It's a very good project, and we'll see like what kind of questions you can see in your interview, and we'll see like how should you prepare for them. And finally, we are going to update our resume to talk about what have you done in that project. Again, you are not going to develop this application. You are responsible for only, setting it up, or you can say running it inside the inside different environments out there. So this is the Capstone project. We'll be kind of developing on, not developing, sorry, we'll be deploying on various different options available there. Yes, there'll be daily assignments. I'll be not daily, weekly assignments I'll be passing on. You'll have to work on that. I'll mention that in a minute, but this is something that you are going to do, right? Someone is raising the hand. Sushil, you are raising hand? Yes, go ahead.
Hey, Amit sir. So, couple of things, right? I saw the detailed plan for next couple of weeks. Some of the things like you were talking about AWS, right? I know there's so many professionals also join there working on Azure. So, can you please include Azure as well? Maybe one session to deploy on Azure as well.
I showed that here. I am going to talk about this. I mentioned it. It's not like only AWS because there are other cloud providers also. I'll be showing EC2 instance and deployment of it here and here also. Once I show it for
Okay.
EC2 instance, the same should be repeated on Azure and GCP. Only command will change is how to connect it. That's it. Once I connect to EC2 instance or once I connect to virtual machine, it doesn't matter whether it is running in AWS or GCP or Azure, because virtualization is the technique, or it's a feature with which we can create the virtual machines somewhere in the cloud. Either you can do it on AWS or GCP or Azure. Once the virtual machine is available, you can start configuring. Doesn't matter whether it is running on cloud provider 1 or 2 or 3. So I'll be showing one example of EC2 instance as I just mentioned here. So this means once I show you this, you can also do it on virtual machine, let's say on GCP as well as an Azure. So one example I'll include it here, or one installation or deployment will happen here, and then we'll go for Dockerizing it and running it somewhere on EKS. Okay, so
Okay.
it will be there.
That helps. The another one regarding that the testing automation, right? I think you said Selenium and someone else also asking Playwright. I think you say Playwright is getting popular as well.
Yeah,
Not sure we have a scope to
I
have
think we'll be
one
talking
use
about
case for
that.
Playwright.
Okay, if time permits, I will, but Selenium is already kind of popular in the market. So we'll be talking about Selenium at least in one example, in one session there. Okay, but if time permits, I can talk about the other options as well. Okay, sir.
Sure. And the last one is observability. I think I saw in your email or somewhere you would also listed the elk, right?
Which
For the
one?
log elk, ELK.
ELK, yeah, yeah.
Yeah.
ELK, I was thinking about to get it done later if time permits, because this one, Prometheus and Grafana, is more important. But if you think you want to go for it, I have no option to go for Elastic. I mean, it's called Elastic Ash. The ELK stack it is called as. Definitely, we can definitely go for that as well. Once the
Okay.
Kubernetes is in place, you can go for any of these options available. Prometheus and Grafana, not only they are simple, but they are industry standards when you go for Kubernetes. That's the reason why I wanted to include that. We'll see. We'll go for ELK as well if time permits, but these two are something which are mandatory when you go for Kubernetes. Okay, sir?
Okay. That helps. Thank you. Thank you, sir.
No problem. Absolutely. Uh, who's that? Sandesh, organization, I see that when the code is merged and the TL starts the build, until the build is going on successfully, we are seeing 404. So how Flipkart and Amazon achieve these things when they deploy the changes without going the site down? Very good question. Sandesh, there are two types of deployments happen. One is like you can replace all the different, I call them pod, or I can call them as virtual machines at once, and there is something called as A/B testing, or you can say blue-green deployment. Blue-green deployment means it's not like all the services will go down and you see 404. It's like half of them will get the new instance, the new machine or new changes, and half of them will still run the old versions. Once the half of them will start working with the newer versions, they will come up, and once they start running, the other half go down and they will start getting up with the new version. That way your application will never down. The only I don't say problem, but only way here is few of the users will see new and few of the users will see the old version of it, time being while the deployment is going on. That's another way to do it, Sandesh. What you see here is all of them go down and all of them come up with the new version. It is risky because there is a downtime required in that case. If you don't want your application to go down at any cost, this is called as a blue-green deployment. So blue-green deployment is where the application will be kind of using half of its strength with newer and half of its strength with the older version of it. And this is how in Kubernetes this works, because in Kubernetes there is another service called as a deployment. The name itself is called as a deployment. And when you go for deployment, this by default supports a blue-green deployment. So your application will not go for will not go down at all. It's called a rolling update. Absolutely, Hemant. This is called a rolling update or blue-green deployment. So that is something which by default done in Kubernetes by using deployment. So we'll not face this problem, Sandesh, anymore. Yes. After this, will there be AI ops course? Yes, yes. I'll talk about it in tomorrow's session. Today, I'll just talking about something like the overview of it. I'll start talking about the DevOps here. But unless I talk about DevOps, I can't talk about AI the DevOps for AI is called ML ops. I'll talk about it in tomorrow's session. By the way, just for your understanding, my motive here, or my, I would say the requirement here is like, because AI is very popular and people really want to get the AI models deployed in the cloud or deploy somewhere in the application, somewhere in the industry. So how do they do that? There is something called an ML ops, or it's also called as LLM ops. It's called as ML for ops, or ML with ops and LLM with ops. Now, to understand ML ops or LLM ops, these are the prerequisites. Without this, without these tools, you cannot move to ML ops. So this course is kind of divided. MLOps course is divided into two parts. It's called the DevOps and this called the MLOps. MLOps has a requirement on the DevOps. Those who are interested doing the MLOps, once the DevOps is over, there is a 2 or 3 weeks course. Tentatively we are saying 2 weeks, but I'm sure it will go 3 to 4 weeks also if required. So we'll go for that MLOps course there. There we'll talk about the different set of tools. I'll talk about those tools in tomorrow's session, because tomorrow we'll be comparing DevOps and MLOps, and you will understand like how the ML and DevOps will go hand in hand. And I know, and you also know, that it's very important to know the ML in today's world or AI in today's world. And that's the reason why this course is a kind of prerequisite of the next course. So those who are waiting for that, yes, it's not called the AI ops, it's called as the ML ops. So we'll be talking about the Q flow, ML flow, and there are different tools, DVC and other stuff. We'll talk about them in tomorrow's session. Okay. So Heman, stay tuned for tomorrow. Omkar, EC2 instance, will there be a manual deployment like pulling the code from Git, or building starting with the first deployment on all of them will be manual. Later on, we'll configure the Jenkins, GitHub Actions, and Argo CD to do that job automatically. But first deployment will always be manual. So you will see the frustration of deploying the application by hand and how many steps that you have to do. And if you miss one of them, how you will see the application won't work. So we'll see that frustration, and then we'll go for automating it with the help of CI/CD pipeline, right? Paddy, on OpenTelemetry, like standard or a protocol, could you clarify? OpenTelemetry, it's not a protocol itself. It's kind of an open source e-commerce development or open e-commerce application to demonstrate how do we develop an application in microservices architecture. How they should talk to each other. Or that's a standard way to implement a microservice application. That's why we are using this OpenTelemetry. The another reason why I chose this is because it's a bigger application and there are many services which are using different languages. Another reason why you should know how do I get one application developed in one language containerized, another application developed in another language containerized, and how should they talk with each other. That's the reason I chose OpenTelemetry. Okay, it's a bigger application. That's a major reason why we are using it. Sagar, will we get the notes? We are going to, I'm going to pass every single note, every single drawing, every single step, every single word that I'm writing here. I am a fan of, writing a lot of things and drawing a lot of things on iPad. So I'll be sharing every damn thing which you see here on the screen with you on GitHub repository, starting from today itself. Means you will get to know the repository in a day or two, but it will be kind of committed in the GitHub repository starting from today itself. No problem, Sandesh. Paddy, I think you got it. You gonna go cover the Kafka administration and DevOps? No, Kafka is not included here. If you have any kind of requirement, you talk to me. I can arrange another session or two, but it's not a part of the syllabus here because Kafka, then there's RabbitMQ, and there are many other message queue applications. I will show you where in the architecture they are used, because here I have to talk about something called as microservices. I think I mentioned it. For containerization, we have to go for microservices architecture. There, I have to talk about Kafka, but Kafka administration is not a part of it. Okay. Scaling will work only for the front end and the back end, or will it be work for database as well? Yes, it's a good question, Deepak. I'll be showing the scaling for both of them. I mean, the front end, back end, that's an application, and databases as well. There are different strategies will be applied for deploying for scaling the databases. Like for example, when you are going for Mongo, I'll be choosing the Mongo when it comes to when it comes to scaling a database, because Mongo is very popular in NoSQL. I'll show an example of MySQL as well, but more or less, Mongo is preferred when you are going for the scaling application, scaling databases. So I'll show an example of database as well, which is different than the front end and back end application. The configuration is totally different for that. And there we'll talk about daemon set. In Kubernetes, I'm talking about daemon set and stateful set. Why am I not writing it? Hold on. So when we go for it, databases, as I said, like Kubernetes is huge. It's vast, Kubernetes CK itself will take 5 more weeks to do that. We're not going to go for that, but we'll be talking about at least a week and a half. So there we'll be talking about something called as the daemon state, it's called as. And then there is called as a stateful state. So we'll talk about this, like what do you mean by that and how it is used here. And this is mainly used for database scaling. Who's that? Deepak. So that's kind of answer you're looking for. Pooja, this is helpful for a DevOps profile only, or it can be beneficial to SD as well. Both of you, I mean the DevOps as well as SD, both of you will get benefited with this. Yes, mostly here to know the Docker and the Kubernetes in details. Yes, that's what we are kind of focusing on. Docker and Kubernetes are very required tools in the DevOps category. So this will not help you. This will not only help the DevOps, this will also help the SDs as well. Akshay, are we going to talk about the Gradle and JFrog? Not Gradle. I think I didn't mention it here, but we'll be talking about few repositories concept here. So when I say repositories, these are called as artifact repositories. Artifact repositories, they are known as. Nothing to do with the cloud. This is a completely different topic. So artifact repositories, here I will talk about something called the JFrog, very popular artifact repository. There is another one, we will not talk about it though, but there is another popular one, something called the Nexus. If you want, you can go on your own for Nexus. I'll guide you how to do it, but will not kind of use it. But thanks for reminding me, Akshay. We'll be talking about a JFrog as well. That is important for us to collect all the artifacts, and we'll be connecting it using the Docker as well as Kubernetes. Okay. I'll show you this example there. It's called the JFrog artifact repository. Yashwan, GitHub basics and commands will be covered. Yes, this is mandatory. So we'll talk about that. When you say something like GitOps, I think somewhere I mentioned here GitOps. So that will cover all the basic Git commands there, like how do we create a repository, pull, push, clone, so on and so forth. Yashwant. Okay. Manisha, is it really going to help us, because we'll be getting all of this stuff starting from the notes, hands-on practice? Yes, of course, this will. I know. That's the reason. This will be not only the notes, that will be a kind of, I'll give the separate notes for commands and the separate notes for theoretical discussion as well. But here in the class, we'll be talking about theory and then we'll go for practical. Both of them, literally hands-on will be covered here. Heman, will you please also show another course for KDS certification along with the Linux? Yes, we are planning it. We already have done that earlier also for CK and CKD separately, not for this one. There was one CK and CKD also. We'll see that in upcoming session, like depending on how many of you are interested. Sanjana, this all topic will practice and cover in 2 months. We have to. We have no option. We'll have to. Bhushan, 3 persons will have joined from QA, networking, microarchitecture, and blah blah blah. We have 14 years of experience. Hope it will help to explain where it helps. Yes, Bhushan, this will be helpful for you no matter where you are, whether you are in a freshers level, whether you are in the intermediate, or whether you are in a senior level. This information will be helpful for you at any level. More the level you are going at, more this information becomes not only important but crucial for you to know. So it's going to help you also. This will help you to become a good architect. Knowing all of them, you can decide like how your application must be developed. And let me tell you, the deployment will decide how the architecture will be implemented in the first part. That's why knowing where it is going to get deployed will help you to design the architecture of your application, like microservices one, for example. Okay. As a software developer, how the DevOps career growth? There is a good growth in DevOps, and yes, I'll talk about this towards the end of it. Like what will help you to grow in a DevOps career as well. Okay. Which programming language do we use for DevOps, Python or Java? It does not matter because we are not going to develop a single application here. We'll be developing a stack, or you can say the pipelines, but not a single application. For pipelines, for example, if you go for Jenkins, we are going to use a Groovy. That's kind of a DSL. It's called a domain specific language in Jenkins. For GitHub Action, we'll be using YAML. So you don't need to have any Java, Python, or any programming knowledge at all. If you are a good developer, it's a good. There's no problem with that. Having a developer, it's kind of added advantage here, but it's not mandatory to be a developer. Okay. So we'll be kind of writing the scripts in a different languages out there, right? Yes, Deepak, definitely. Gajanan, after completing this course, how many days will be recording available? I'll mention that in a second. Nashik, okay. I think better for me to go further and give you first understanding of what things are there and what should you do. I mean, if you want to go for all of this stuff here, what I mentioned here, I mean, all of this stuff here in next 2 to 3 months, not 2 months, what different things you should follow. I mean, first of all, related to the timing. Now, when you see, or when you must have seen that poster, we already have mentioned, the classes will be conducted on every Monday to Thursday from 9 to 11 p.m., right? We start exactly at 9 o'clock. We generally generally stop at 11 o'clock. But if time requires, or if that particular session requires more time, we'll sit a little bit longer as well. So be ready for that. Sometimes, because it's like, the one entire session will cover multiple things. So sometimes it may stretch up to 11:30, sometimes it may go to 11:45 to 12 as well. Just giving you a heads up so you can prepare accordingly. I know most of you are working professionals, you are working throughout the day and then you are coming here, you must be tired. So please forgive me for that. Sometimes if it is needed, you have to stay a little bit longer, but normally it will be 9 to 11. Every alternate Friday, we'll be talking about a QA session. I mean, QA is for understanding the question. See, there are many people who will keep on asking the questions. Unfortunately, it's not possible for me to keep answering your questions every single time. The reason here is if I keep answering the questions, we will not be able to focus on the topic, or will not be able to complete the topic as well. That's the reason, whatever the important questions you are having, if you think like, okay, I need to get an answer of that, you note it down, and on Friday we'll be arranging one QA session exactly on the same time, 9 to 11. We'll be providing a recording of that as well, and this QA session will help you to get the answers of your question, plus ask more questions according to or on the topic that we have covered so far. So every alternate Friday, every second Friday, we'll be having this QA session on the topics that we have covered so far. Or if you are having some other doubts, like your company is having something like this and you are stuck somewhere, how do you solve that problem, so on and so forth, we'll be discussing all of that question answers in this session called the QA session. Every alternate Friday, we'll be having a QA session on that. Okay, another one. There'll be a Diwali holidays from 20th October to 31st October. We all are from India, and for all of us, Diwali is important, including me. So we'll be having 2 weeks off between 20th to 31st. So please make a note in your calendar also. There'll be no session between 20th to 31st. We'll directly resume on 1st November. Okay, so that's important point. If it is something that you should plan accordingly, like this is something which will be keeping holiday here. Okay, it's a Diwali vacation for all of us. Again, this is my request. Be punctual and join before 5 minutes so that we can start on the scheduled time and probably we can go smoothly. So this is regarding the times. So hopefully if you are having question in your mind, they must have got answered here. Another one, again, I don't have to tell you that because you all are pretty much, I mean, pretty much mature one, but still, it's a common sense, but it's not very common. That's the reason I'm mentioning here. Classroom etiquettes, mute yourself if you're not speaking to avoid the background noise. You must have seen like sometimes, I'm not saying it deliberately, but sometimes people get accidentally unmuted and you start hearing the background noise and that creates a chaos. So if you're not speaking, just keep on mute. Use the raise hand feature to or a chatbot to ask the questions during the sessions. If you are having an important question, put them in a chat box. I'll take a look at it in between because I don't just keep every time to go there to answer your question, because as I said last time, if I keep answering the questions, won't be able to finish the topic. So as and when it is needed, I'll check the questions and I'll answer them if they are important. If they're not important, or if I can see like the answer of those questions is coming up, I'll skip the questions and you automatically will get an answer. And still, if you think like your question is not answered, note it down, ask that in a Friday session, no problem at all, or ask it by raising the hand. Maintain professionalism and respect while interacting with the other peers and instructors. Instructor, it's fine, but other peers talk talk politely. That's the another request I'm having to all of you. Another important point: be actively involved, be attentive, and engage in the discussions, QA sessions, practical exercises. Be vocal, ask the questions n number of times or n number of questions as that come to your mind. Again, I encourage all of you to ask as many questions as you want, but again, don't expect the answer immediately. I either answer that question later in between, or by default you will get the answer if I know that the answer to that question is coming up. So don't get offended. I have no intention to offend any one of you, so don't get offended if I don't answer your question. Okay, it happens. There are hundreds of questions I can see lined up here. It's not possible for me to answer all of them. If it happens, it generally doesn't happen, but if it happens that I couldn't answer your question, make a note of it, ask in the next class, or raise your hand, ask it right now, or maybe put it somewhere and ask it in the next Friday session, whatever suits you. Okay. Again, very important, again, in this point, someone asked a question, will be getting some homeworks, will be getting some assignments. So complete those tasks before the next class, before the next session. I'll be giving some assignments for you on weekly basis. So you have to complete them because every week we'll be changing the tool, so you should be kind of on your toes to complete all those assignments. Post-class activities, like what happens, what should you do after the class is over? Every after class, review the session recording because they will be available immediately on the next day morning, because we are finishing at 11 o'clock morning, 5 o'clock or 6 o'clock maximum. You will be having the session added to your portal. So review that session, read, maybe go through the video one more time if you want. Again, practice those commands out there. Practice hands-on exercises to enforce or to reinforce the concepts discussed during the session. This will help you to remember those concepts and build the knowledge on top of it. And this is important because every next session is dependent upon the previous one. That's why hands-on exercises are very much important. And again, practice as much as you can. Clarify any doubt during the same session or immediately next session so that you will not kind of having that question in your mind continuously bothering you. So that's another point. Someone was asking the question like how much time the recordings will be available. Every class will be recorded without fail, and all the recordings will be available for next 6 months. So probably this is September. You can count. This is like 15th of September. So September, October, November, December, January, February. 15th of February, it will be automatically kind of taken down. It's not something we do it deliberately. It's the policies. That's how it is. The classes will be conducted on Zoom app. I didn't mention it, sorry. The classes will be conducted on a Zoom app only because everyone is having Zoom installed most of the times, and it requires less amount of resources. That's the reason why we are using Zoom. And another problem, not problem, another reason why Zoom Yeshwan, because we are having the licenses of it. That's the reason, Okay, fine. So will there be a session for security on DevOps related stuff on this one? Not separately, but whenever needed, Soman will talk about the DevSec app. What do you mean by that? I'll come back to this point when we go for deploying the application on Kubernetes as well as on something like virtualization on EC2 instance. So it's not a separate session as such, but security has to be implemented while you're deploying the application. So I'll talk about this, what kind of layers of security we should be knowing. Okay. How the AI is going to affect the DevOps role in the future, Neeraj? It's debatable. We'll talk more about that when we go to that topic there. Okay, don't worry, I'll talk about that. I don't have you don't have to have a knowledge of Maven, Gradle, or Ant. Don't no, I mean don't you worry, because we don't have a prerequisite for that. It's not at all needed. Having it, it's good, but it's not needed at all. Can we see how DevOps works in the mobile application? It's not available. I mean, I'm not having any application yet, but if you want, we can see an example of it in between when we go for configuring the Jenkins pipeline there or GitHub pipeline there. We'll see. How do we go for using Go or Python for shell scripting? It's not needed right now. If you can, it's a good, but it's not mandatory though. Okay. As a tester, what's the most important part of this learn from the DevOps? Actually speaking, tester will be kind of, I mean, from testing point of view, this is only a stage inside the Jenkins. Will be configuring the Selenium, or maybe you can say any testing tool out there, unit testing, for example. So that's where the testers knowledge will come into picture. For automation QA, how this course will benefit? This will benefit not only for automation, not automation on the QA side, this will be helping the entire pipeline. So entire pipeline contains the QA tools there. Okay, so they will be needed in order to make the entire pipeline work. So that's how it might help you. Okay, so hopefully those questions that you asked have been answered now. Let me continue further and talk about who am I. So probably we can set some expectation here. So my name is Amit. You already have seen my name there on the poster also. So I'm having more than 18 years of experiences crafting the technology solutions. I am here working as associate director in Sunbeam. At the same time, I'm a passionate freelance developer. I do this both at the same time. So morning 7 o'clock, maybe 8 o'clock, I start the session, but morning 7 o'clock to afternoon 1 o'clock, 1:30 o'clock, I generally deliver the session. I come back at home, and starting from 2:30 till 11 o'clock, I develop the applications for my client. Actually 9 o'clock, because 9 o'clock after that we start this session. But most often 2 to 9 is where I develop the application for my client. So I've explored many different domains, including something like the e-commerce applications, the automation tools, and whatnot. You just tell me, and then I can tell you like how many different type of applications I've developed there. So very complex problem with the model tools and technologies. So develop many type of applications with multiple different requirements of it. I had a privilege of developing many mobile applications. That's where I started my freelance career way back in 2008, to be honest. Numerous. I mean, I just stopped counting. It's more than 150 applications have been developed so far on mobile side of it. Having the both, not only iOS or not only Android, is like Windows Phone and BlackBerry also at that time. If you remember, BlackBerry was one of the phones available at that time. It was very popular. Nowadays, they have committed suicide because they couldn't afford running in the race with iOS and Android. That's the reason. But more or less, it was one of the popular devices at that time. So I developed the applications for Symbian as well, BlackBerry as well, and Windows Phone as well. After that, Windows Phone also committed suicide. Now the only options remaining is like iOS and Android. So I still develop the applications for both iOS and Android using native as well as hybrid. For hybrid, I use React Native rather than using a native script. For iOS and Android platforms, at the same time, I developed the many dynamic websites using PHP. PHP has stopped now because there are very less requirements on that. But today, I'm kind of developing applications for web using Mean and Moon a lot. Mostly it is a React now, but sometimes I get a requirement for Angular as well. So I'm a hardcore developer first, and then the administrator later. I mean, the ops persons later. So I have both the knowledge. Once, when I finished my BCS way back in 2003 to 2005, I worked as a network administrator and kind of, you can say, operating system administrator or local administrator. It was one of the good call center there called it WNS. If you have heard about that, it was in Nasik when I joined there. And I was the only person who was handling the entire routers and almost like 400 machines out there. So I have good thing is like I have both the practical knowledge of it and the theoretical knowledge of it. At the same time, I have gone through RHC. You might have heard about that. RHC stands for Red Hat Certified Engineer. So I completed my RHC there. Same time I completed my CCNA there. Same time I completed my OCP there. OCP for Oracle. Way back in 2006. All of them have got expired now. I don't even advertise them right now because they're kind of gone. But Linux is something which is my first love. So probably you can see, I don't use Windows at all. So I use either Mac or Linux a lot. So when it comes to developing applications, I love the programming languages like C and C++ for the performance, Python because of its simplicity, and I use a lot for AI development today. Those who are from AI, they might know that. JavaScript and TypeScript. JavaScript I use for the React development, and TypeScript I use it for the Angular development. Go, many a times when the application comes to develop in the backend where the performance is needed, I use a Go for that. I mean, most often I use the JavaScript for backend development also as well, using the Express applications. But sometimes if it is needed, I use a TypeScript Nest, Nest, for backend development, which is developed using TypeScript. So I use TypeScript for that as well, backend development as well. And if the performance is required, I prefer using Go on backend side as well. Swift, I use it for iOS development, iOS native development. Kotlin, I use for Android native development. And PHP, nowadays it is gone. I mean, earlier I used to use that for developing the website application or web applications, but now it's kind of having no or very less requirement. I mean, it's been almost like, I would say, a decade now. I have not touched PHP anymore because there are no requirements coming up. That's the reason. DevOps journey includes the CI/CD pipeline, including Jenkins, including GitHub Actions and Argo CD as well. Use all of them in my real world implementations as well. I mean, in a sense, like when the project comes to me, as I'm a freelance developer, as I mentioned, and when a project comes to me, I start the development from scratch. I need to architect the project, I need to write the code, I need to test the applications, I need to deploy the applications. So all of these things, end to end, I'm involved in every single stage there. So when it comes to configure the CI/CD, I prefer using Jenkins, GitHub Actions, as well as Argo CD. When Jenkins is something which I love. GitHub Actions I learned later after I learned Jenkins, after I got certified. Then I came. Then GitHub Action came into my life, and then I started using it. I love that also, but more than that, I love the Jenkins part. Argo CD is very simple when it comes to the Kubernetes configuration. That's the reason I use it most of the times when it has to be deployed using Kubernetes. Not every customer, not every client can afford the Kubernetes cluster. That's the reason I generally do it on both the sides, virtualization as well as containerization. When it is a containerization, I prefer using Argo CD. When it is a virtualization, I prefer using Jenkins, sometimes the GitHub Actions. I mean, GitHub Actions and Argo CD, they generally go hand in hand, but Jenkins is kind of something which I used for virtualization a lot. Automating infrastructure tools using the Terraform and Ansible. Love both of them because once a script is ready, you just need to execute and everything will get done hardly in a minute. You just blink your eyes and your infrastructure will get created. That's the reason I love both of them, Terraform as well as Ansible. Leveraging the cloud platforms like AWS, I love it and I'm using it since 2013 now. It's more than a decade. More than a decade now. So probably AWS is very popular since then, and it is very important for you to know also because there are many services which are absent on other platforms, like GCP and Azure as well. That's why it's called the market leader. So I love AWS there, and I use that AWS also for my real world deployment as well. The robust and scalable applications, containerizing the applications using Docker and orchestrating them by using Docker Swarm and Kubernetes. Docker Swarm generally used for small applications. Nowadays, it is not kind of preferred. Even if it is small applications, still we are kind of using Kubernetes for that. But Kubernetes is something which is you can say, very important in the deployment world because this is where you can develop HA, highly available application there. Now, when it comes to DevOps, I've got the certification from Kubernetes for both application developer and administrator. Both of them are different. Both of them are having different requirements. Both of them are having different mindsets as well. This is administrator. As I mentioned last time, the CK requires you to have a very good hands on Linux, networking, and then Kubernetes. Kubernetes comes at third place. First Linux, second networking, and then comes the Kubernetes. That's administrator side of it. When it comes to application developer from the Kubernetes, you have to know Kubernetes a lot, like Kubernetes, not networking, not installation, not cluster configuration, nothing sort of that. When you are application developer, the cluster is already ready for you. Someone or administrator will administrator will configure cluster and will pass it on to you. You as application developer will write all those pods, services, deployment objects, and then you will run your application inside the cluster. So your role as application developer is totally different in Kubernetes, and your role as an administrator in Kubernetes is totally different, so both of them are having different requirements as well. So I have gone for both of them and love that the tool itself, the Kubernetes. Another one is Jenkins, the logo which you see here, the person who is holding the towel, or you can say the napkin in his hand, this person is called as a Jenkins, So this person, or this Jenkins tools, is kind of, you can say, in the market since 1984, I believe, So this is a very kind of, you can say, a old tool. And when I say old, it's not the old, it's matured tool. So it has seen more than 2 decades. That means it already has gone through that entire evolution, that people were kind of facing this problem and people were looking for solutions, and these guys have integrated that. So it's very mature tool as well. So got certification for that. Docker, as I said, it's very important for me because when I started using Dockers around 2013 or so, that's where the Docker started getting its popularity. The 2014 is where I started using Docker as a full-fledged tool out there. At that time, it was very new in the market also. And at the same year, I started using the Kubernetes. 2015, I started using Kubernetes. 2014, Kubernetes was kind of open sourced by Google, and 2015, in January or February 2015, I don't remember exactly, but 2015 I started using Kubernetes. So Docker and Kubernetes are part and parcel of my life. I can't live without both of them. Again, Linux, as I said, my first love, because when I started as an official network person, there I was managing all the Linux systems, all the Windows servers, as well on that WNS servers that's out there. I also have got other certification, but they are expired, as I said, RHC and RSC. But Linux Plus, I hope it is still there. I didn't check it, but it's still there. And recently, last year, I believe, I got the certifications for the Security Plus as well from CompTIA. That's for making sure that we are using all the security, maybe we can say the security rules, so that the application that I develop will be kind of secure enough that no one will be attacking. There will be no vulnerabilities. I mean, it's not like no vulnerabilities, less vulnerabilities that I can say. So security is also kind of very important here, and that's a reason to showcase that I know security to my clients. I've gone through that certification as well. So probably, these are the things that come from the DevOps side of it. Just to give an idea, like you're in a good hands, so you can ask in any question on any of those tools there. So probably this will give you a kind of a context, like who am I and what kind of the expectation you can have. Okay. So this is not like I'm kind of I'm playing a I'm playing a kind of musical instrument here, but all I'm trying to say here, my own trumpet is called as, but it's not like I'm doing that. I'm just telling you that who am I, so you can set your expectations and ask the questions accordingly. Okay. No problem. Yes. So that's all about me. I generally don't talk about myself a lot, but sometimes, when you're starting in the beginning, it's better to talk about yourself. So probably you can set some expectations from that as well. Paddy, most of the developers tools Terraform will work with the on-prem devices as well. Yes, and that's what we are going to do. We are going to use both on-prem as well as on cloud. So you will get an idea about how do you do that installation on your machine and how do you configure it on the cloud as well. We'll do it, both of them. Thanks for really appreciate your knowledge. No problem. It's my pleasure, guys. Don't be surprised if they start correcting them every now and then. No problem, sir. Hemant, no problem at all. Fine. So this is all about the course. This is all about what we are going to cover here. And this is all about the instructions that I wanted to kind of give you so that, you can start behaving accordingly. Okay. Now, this is all about me. Now we'll start talking about the first part of it. It's called as the software engineering. Today, we'll just go through only a couple of things, and then more on that, more on the, DevOps cycle and other stuff. We'll talk in tomorrow's session. Before we go for that, anyone having any question? Oh, by the way, I forgot to mention that. I think this will be kind of a last batch for DevOps. Probably next 2 to 3 years, I'm not planning any kind of DevOps batch directly, if it is needed, then we'll go for MLOps, but DevOps, I'm kind of bit tired because it's like too many things and people get, exhausted in between. Many of you, like it's almost like 137 when the session started, it's now 122, almost like almost 15 people have gone. So you see how eagerly they join and how early they got frustrated. And I can bet on that, even if you're joining, again, I'm betting on that half of the students will get tired and will get exhausted and will live in between. That's an experience, and it frustrates me a lot. Like, this is so exciting world, and this something like you give you sky limiting opportunities there, but people do not understand the importance of it. That's why sometimes it gives me a frustration, and that's the reason I think it will be the last batch. After that, move at least for next 2 to 3 years, will not go for that. So anyway, so that's all about it. Now we'll start talking about the software engineering, and we'll quickly go through something called as a software development life cycle. Okay. So when we go for software development life cycle, probably you must have heard about it. It's called an SDLC. If you haven't heard about that, it is the way you are going to develop an application from end to end, from scratch, from nothing to deploying that application in the real world. When you want to do this, when you want to develop an application from nothing, you start with something called as a planning. Planning is the first stage. What do you do there? In the planning part, you are going to start something called as a requirement gathering. It is known as, means you start getting the requirement from your customers. You start understanding what are they looking for, and accordingly you will start preparing those requirements out there. So this is the very first stage where the requirement will be gathered and the requirement will be analyzed. So this is called as a requirement gathering and a requirement analysis. They are the two jobs of planning stage: requirement gathering and requirement analysis. Understanding the requirements is very important before you take any decision there. So this is requirement gathering and requirement analysis. The next stage, once you are having all the requirements gathered, you will go for defining them. Defining means you put them in a piece of paper, or you can say in a document, and you can show to your client, and both you and your client will agree on what kind of expectations that you can expect, or what expectation you can set for this entire project. This will lead to creation of a document called as SRS. It is called as Software Requirement Specification Document. Better for me to write it here. This is known as a software requirement specification. So this is the document which will contain all the requirements specification. This is the document which contains all the requirements that you as a developer will work on, and a client as the one who is going to pay the services will get from you. So this contains every damn thing you want to get developed in your project. It's called as SRS document. It's called as software requirement specification. This is going to be a bible for both developers, testers, or ops. So both of these people or both of these teams will understand what to be developed and what to be deployed from SRS. Then comes the designing. Designing means you are going to design the entire application screens, or you can say the screen flow, or you can say the database, and so on and so forth. This stage is where you can create a design document specification. Design document specification. This means you are going to design what different screens are available, what is the database, and so on and so forth. So this is like the screen flow, or you can say the database design. All of them will be included inside the design, even the screens as well. If it is a Geo application, this is where the design comes into picture. It's like a blueprint we are creating here. Once the blueprint is ready, once the design is ready, here the developers will come and start developing the application. This is where the application is going to get built. This is where you can say the programming, or you can say the development is going to be done. So programming or development, you can say, will be done inside the building stage. This is where the developers will come into picture. Now, no project will get deployed in the market unless and until it gets well tested, which is done in the very next stage called as testing. So what's the testing? Testing means getting your application well tested by using variety of options. For example, when you come to the testing, there are two types. One is called as automation or test automation, or it is also known, or the another one is called as the manual testing. So it's going to be like test automation or manual testing. There are two types. There are three methods available. It's called as a white box testing. Means the tester who is going to test the application will be knowing ins and outs of the project. The person is having an access to the source code. Person can see what the developer has done. It's a very costly, at the same time very very crucial to see like what the developer has done and suggest the options available on the algorithmic, or you can say the code level. So it's a very tough job as well, white box testing. The simplest job is something called as a black box testing. Black box testing. And lastly, it's a combination of them is called as the gray box testing. So there are three methods: white box testing, black box testing, and gray box testing. And there are two levels available here. One is called as the functional level, and the second one is called as a non-functional level. Now, I'll not write it, but when you go for functional level, there are different levels like unit testing means at the function level, then system testing, integration testing, end-to-end testing, UAT, user acceptance testing, regression testing, alpha testing, and beta testing. So there are 8 different ways the functional testing will be done. Under non-functional testing, there'll be stress testing, load testing, security testing, usability testing, and there are a bunch of other options out there, so that is how the application will get well tested. And once the testing is over, you will want to deploy the application here. And when I say I want to deploy the application, this will be available for the public or the end users. There are again 3 ways, as I mentioned earlier. So when you go for deployment, the first option, which is the oldest of all, called as a traditional deployment. Traditional deployment meaning you are going to deploy the application using the traditional, meaning the physical machines. We never use physical machine in today's world just because they are very costly and there is no need of going with capital expenditure. Now, what's a capital expenditure, capex and opex? We'll talk about that in the cloud version, but right now we generally do not do it anymore. If you want to deploy the application, either we go for virtualized deployment using virtual machines, or we go for containerized deployment where the containers are used to deploy your application. Containerization or containerized deployment by using something called as the containers. So VMs or containers, these are the options for us when it comes to deploying the application in the real world today. So there are 6 different stages, as you can see here, starting with the planning where we do the requirement gathering and requirement analysis. Then it comes to the defining where we define all the requirements specifications inside that application that you are developing. Then we go for designing the screens, the screen flows, database, and all of that stuff, which you are going to essentially use later for building the application, where the developers will come and develop the application. In testing, the tester will test the application, and in deployment, the ops people will make sure the application is accessible by end users, or they will make it accessible to the end users, either of the options available, virtualized or containerized way. Traditional is gone. So this is defined as a software development lifecycle, or as a way to develop the application from nothing to the publicly accessible application out there. Now, this is a theoretical understanding of it, but practically, if you want to implement SDLC, there are different models, and one of the oldest model is called as a waterfall model. Now, what's a waterfall model? Waterfall model is the way where the application is going to get developed by using all of these stages out there. As you can see, there are 6 stages here. Out of that, the first stage is something as a requirement specification. I mean, the requirement specification is exactly similar to what we just discussed earlier as something like the combination of first two, that's called as a the gathering, the requirement gathering, requirement analysis, and the requirement specification. So it's like the combination of first two, that's called as a planning and defining. It's a combination of these two. Here in waterfall, it's called as requirement specification. Then comes the designing. It's called the system designing. So earlier what we said designing, here it is called as a system design. Then it comes to design implementation, which means it's the programming or building or developing an application. Then it comes to the verification and testing, where the application will get well tested, as I mentioned earlier. So testing in SDLC, here it's called as verification and testing. Then comes the system deployment, where the application will get deployed by using virtualized or containerized way. And lastly, it's a software maintenance. When there is a need to modify something, the application will get updated in this particular stage. Now, why is it called the waterfall model? It's called the waterfall model because like waterfall, it goes from top to bottom, and like waterfall, you cannot come back in a reverse direction. Like water cannot go from bottom to top. It always come from top to bottom, so that's why this model is called as a waterfall model. So for example, if something you found here that, hey, you missed this particular functionality, you can't go back here in the previous step and start implementing again. No, you will get it done as is, you complete it, and then you start from here again, you come here again, you come here, and then make the changes there. So in short, like water or like waterfall, it always goes from top to bottom. There is no reverse direction. You can't just go back to the previous stage and fix it immediately. And this is the problem, that whenever you are using the waterfall model, we have to complete all the stages, and then and only then you can restart it from the first step. And that is the reason it takes a lot of time to develop application using waterfall model. Months to years. Morely, it's like years time when you are going for waterfall model. And that's what happening earlier when people were developing the applications. And that's the reason clients were very frustrated, because till the time the application was getting developed, the client was not able to see what's happening in between. And that is a major reason why they wanted to change this waterfall model to something. So as you see here, we, for example, are developing an e-commerce application. So we consider the e-commerce application as a whole. So the whole e-commerce applications requirements will be specified or gathered. The whole e-commerce application will be designed. Whole e-commerce applications implementation will happen. The whole e-commerce application testing, whole e-commerce application will get deployed, and whole application e-commerce application will get maintained. In a sense, if you see like something is missing, you cannot just go back here. The whole e-commerce application will get deployed, and then its maintenance will start, and then you will to get a chance to modify or update that application. And that was taking a hell lot of time. That's the reason people started thinking about a better option, and the better option they found is something called as the DevOps or Agile. So when it comes to Agile, people started taking the responsibilities into picture, and then they started dividing those responsibilities into something called as the dev and ops, where in Agile they started giving some responsibilities to developers separately and operations team separately. Now when you talk about the entities and the responsibilities, I mean all of them involved in developing an application, the first entity is known as the developers or testers. In a general terminology, we call this as a we call this as a dev team. Please remember, excuse me, dev in the DevOps is not only developers. Dev in the DevOps is something called as a dev plus testers. In a sense, developers plus tester. That's called as a developer team. So those who are developers, they can easily understand the main responsibility of a developer is to develop an application, write the code, package an application, means create a package, deployable package out of it, fix the bugs if there are any, and maintain the application by adding the new features as and when the client asks you to develop. So these are the major responsibilities of a developer. When you are a tester or in DevOps, in the dev team, when there's a tester, the tester's main job is to thoroughly test the application using manual or automation way, like what we discussed earlier, and report the bugs to the developer. So developer will fix the bugs and take care of fixing those issues and deploying the latest version of it. This is the developers and the testers team known as a dev team. Now, as you can see, both of them are having different roles to play. Like the developer is going to play a role of developing an application, and tester is going to play a role of testing an application. When it comes to operations team, this is doing more than developers and testers. So operations team is responsible for number one, systems uptime and availability, making sure the application is continuously working. This is where monitoring is required. Monitoring, if you remember, I mentioned couple of tools like Nagios, Grafana, and Prometheus used here to check if the system is up and running, availability and uptime of that application. Incidents response and resolution. When I say incidents, something bad has happened, like your application has gone down or application has got hacked. This is called an incidents. So incidents responding and incidents reporting, both of them are important here from the operations perspective. They will be on their toes when they deploy the new version of it, because they need to keep checking if the application is running, if people are able to access the application, if it is not going down, so on and so forth. Performance monitoring and performance optimization, again, it's a part of monitoring itself. So unless you see the application is working very well, you will not sit quietly, so you keep on looking at it continuously. It's why it's called as a continuous monitoring when it comes to DevOps. Another important point, implementing security, because unless and until application is secure, you again cannot make your data secure. So application means the one the users will enter to get the data. So if you want a secure data, application must be secure. Security implementation is very important in today's world. Backup and disaster recovery. Every now and then, something may go bad. So better you always will take a backup of your application and maybe backup of your database. This is where scripting is involved. This is where the scripting is kind of involved. Then you go for capacity planning. How many resources are required? For example, if I want to deploy this application, how many EC2 instances will be required? Or what's the cluster size required? So on and so forth. That's called the capacity planning. And finally, the automation. You don't want to do everything manually. You want to automate it. And for automation reason, why we are here for DevOps. This is the major reason why DevOps is really important. Automation. And under automation, you can see there are different things. So as I said, this was the problem earlier people were facing. So they divided these roles into two different teams, the dev team and operations team, and they come up with something called as agile development. So agile development is something which we are using today. So what's an agile? Agile development means first planning for a sprint. Everything happens in terms of something called as a sprint. A sprint, it means it's a kind of a event which will be captured in 1 to 4 weeks. So whatever that you want to do, you want to divide into small portions called as the sprints, and then you go for you go for creating a sprint, and then you go for implementing them. So you start planning for a sprint, you start designing it, then you go for developing that sprint here, or you can go for testing it, all the things that you have developed so far. Then you go for deploying them, and then you go for getting the feedback from your client. Not that you as a you as a DevOps will do anything with that, but this is something maybe you can say it's like a dev team's job to develop the application sprint by sprint, or you can say chunk by chunk. Call that sprint as a chunk for now, and this will be kind of executed round the clock. You get certain functionalities implemented like this. Once they are done, go for the next one. Once they are done, go for the next one. Once they are done, go for next one. Till the time the project is finished, you are going to see multiple sprints have already been executed. This is given by agile development. The only problem with the agile is like agile talks about getting this application developed in chunks. Those chunks are called as sprint. And this is what the benefit as well as the problem of a agile development here. Now, if you look at the waterfall versus agile, you will see that in waterfall model, we consider the entire project as a whole. In a sense, when the project starts, this project has got so big that I'm not sure whether I'll be able to deliver it or not. So you get scared of looking at the sheer volume or sheer the size of it. This is the waterfall process. You design the whole application. If you can recall, I mentioned this. You design the whole application, you code or you develop the whole application, you test the whole application, and you deploy the whole application. This is what the waterfall model does, and that's why it takes a lot of time to develop an application using waterfall model. So what is the solution then? The solution for this problem is to go for agile process. It's like what Britishers have used against India to rule India for 150 years, divide and conquer. So instead of looking at the whole big project, you keep on dividing it into the smaller portions, and that smaller portion here is called as a sprint. So sprint is, you can say, a part of your project which you can finish in hardly a week or so. So instead of working as a whole project, you divide into small pieces, small chunks, small sprints, and start developing them here. It is so much better delivering this project in a bite-sized sections. So bite-sized section means it's like a small sprint that you are going to work on. Small set of requirements you will take, and small set of requirements you are going to work on. This is what it recommends. You get a small portions here, design it, code it, test it. Again, take the next set of requirements, design them, code them, test them, design them, code them, test them, design them, code them, test them, till you are done with that. And towards the end of it, you go for deploying the whole application. This is what Agile does. So this is what Agile says. Agile says, I don't want to develop the whole application at once, like what the waterfall model was doing. I'll divide that application into smaller portions, and then I'll keep looking at sprint by sprint, or you can say portion by portion, or chunk by chunk design, coding, and deployment here. And deployment will be done at the end of it, towards the end of it. This is what the agile says. But in the real world, the client wants to see every after a sprint to check like what's the current progress, which means once you're done with this particular part, this particular sprint, you want to deploy it here, whatever that you have done. After this sprint, you want to deploy it here. After this sprint, you want to deploy here, and keep on doing it till the project finishes. Which means if you see here, the deployment happens every now and then, and deployment itself is a very important, at the same time consuming process. Deployment means literally copying everything to a certain process, certain resources, making sure everything is working, configuring the pipelines, and it takes lot of time. And that's why this portion can be automated by using DevOps. This is where the DevOps comes into picture. So what exactly is a DevOps? I'll answer that question in tomorrow's session. But right now, you can see that this is the waterfall model. This is the agile process. This is what agile process recommends. But in the real world, I want to keep deploying it in every after sprint is done. And that's why we want to use a DevOps. A DevOps is a kind of an automation to what agile has given to the world. So DevOps is a kind of combination, or you can say it's a mixture of a dev plus ops. It's a collaboration between the developers and ops. I'll explain that in tomorrow's session one more time. And then we'll talk about something called as a DevOps lifecycle. This is a very important point in tomorrow's session. Once it is done, I'll talk about what do you mean by something called an ML ops lifecycle. And then we'll see how DevOps and ML ops can be considered as, maybe you can say, going hand in hand, or they are kind of interdependent of it. ML ops depends upon the DevOps. How and why, we'll talk about that in tomorrow's session. I think this is something will give you a quick idea about what exactly the SDLC is, what's the waterfall model, what is the dev team and operations team, and what exactly the agile development means. I think it is enough for today's understanding. Tomorrow we'll cover the next part.